So for question 16, we have to determine our value R and alpha, where our value R greater than 0 means our value R only accept positive value, and the alpha is a first quadrant angle between 0 and 90, so that our 3 sine theta minus 4 cos theta can be expressed in the R sine compound angle form. So means that we have two terms trigonometry here, then we express in the single term using compound angle sign. So from here we have to find out when we want to express we want to express in this form what is our R, what is our alpha. So data they will be same. Data there is the data original that in these equations. So from this we are going to take up we are going to take out our expressions here, 3 sine theta minus 4 cos theta, going to express in this form, so that r sine theta minus alpha, so sine theta minus alpha is our compound angle. So we will expand our compound angle sine A minus B. So sine A minus B, where our A here referring to theta, and then the B here referring to alpha. So the operation is minus. So minus. So therefore the operation here also following minus. So when we expand our compound angle for sine, we will get sine A. So means that I will get sine theta and then cos B, cos alpha minus cos A, which is theta, then sine alpha. So we continue our expansion for R, multiply our R will equal to R sine theta cos alpha minus R cos theta sine alpha. So you can see here when we expand our compound angle formula, when we expand our compound angle here using the formula here, so the expanded form here actually is equal to this, where you can see something sine theta is referring to the first term here, and something cos theta is referring to the second terms in our questions, 3 sine x minus cos 4 cos theta. So from here we can get two information in order to find out what is our R and alpha. So we're going to compare. We are going to compare our expanded form with our questions. So when we compare sine theta, the multiplier or the coefficient of sine theta, the coefficient of sine theta is 3. Means that our R cos alpha is 3. Because the coefficient for sine theta is R cos alpha, it is equals to 3. So operation is same minus. Then for the next term, we compare for cos theta. So we can see the cos theta here. The coefficient for cos theta is R sine alpha. So R sine alpha will equals to 4. So we have two information in order to find out what is our R and alpha. So we have two unknown here. What is our R? What is our alpha? So that's why we have two equations in order to help us find out what is our R and alpha. So how to solve these two simultaneous? So in order to get alpha, we can search for the terms tangent, idea of tangent. So sine over cos we can get tangent. So we will use equation 2 divide by equation 1. At the same time, we will notice that our unknown R will be eliminated. So this is how we solve our simultaneous equation. So when we do division, sine over cos, which is equation 2 over 1, our R is eliminated. Then straight away we can get our constant alpha. So our constant alpha here will be in terms of tangent, because sine over cos is tangent. Then we find our alpha, just move our tangent. So when we have shift tangent 4 over 3, that will be 53.1 angle. So our angle alpha It's just referring to the basic angle, which is between 0 and 90 degrees. Now, in order to find our R, we will use identity formula. So identity formula is talking about sine squared A, sine squared theta plus cos square theta, they will equals to 1. So you can see our trigo is in power 2. Sine square plus cos square will equals to 1. So in order to get my R, we will try to reach this cos square and sine square to identity formula. So that's why our equation we are going to square it. So we will do equation 2 square plus equation 1 square. So when I have equation 2 square, this r will automatically square and then sine square alpha plus equation 1 square here, so the r square there, r will become square, cos also square. The value will be 4 square plus 3 square. So we can take out our r square, factorize out our r square, and then we will see sine square alpha plus cos square alpha. So from here we eliminate our alpha, which is using identity formula, sine square plus cos square equals to 1. So finally, our value r squared is equal to 25. So we're not going to consider negative value, although when we want to move our square will be positive negative for 25, but our r only consider positive value. So we will just straight focus to the positive value, square root 25, which is equals to 5. So now we managed to find our constant alpha and r, means that go back to the original questions here. When we have two terms of single trigo sine plus minus cos, we managed to express it in a single term of sine. So we write back our answer. That will be 3 sine theta minus 4 cos theta, which is equals to r. Our r, we getting the answer of 5. Sine theta minus alpha, alpha is 53.1. So you can notice that from two basic trigo, now we're going to express in a one single basic trigo here. So this is the usage of R compound angle format. So from here we see what is important. So of course, expand our compound angle in order to get our two equation. And then finding our constant r and constant alpha, so that we manage to express it. So 1 mark should be go to the expression. So this answer is for both. So we go for the question B. So now they're giving here, they say hence use the result before this. This is my result in my part A. Now we're going to solve this equation. So when we want to solve this equation, this form of equation they've given us is not in trigo and then angle value. Equals to value. We must able to simplify our equation, whether using factorization or using this R form or using T substitution, in order we can get this form, get a single trigo angle equals to value. So from our questions here, when we have 3 sine theta minus 4 cos theta equals to 2, you can notice that actually the equation they're given here, we can express, we already expressed it in part A in terms of single trigo only. So we use that result, we substitute that result where this 3 sine minus 4 cos is equals to 5. sine theta minus 53.1. Then you will notice that we are close to this format, the format that we can solve. So we need to move the value 5 to the right hand side. Then we achieve three goal, which is sine, angle is theta minus 53.1, and then value is 2 over 5. So this is the format that we can solve for our equation. Means we can find out our theta. So the step of solving, involving four step of solving. The first one, it will be the range. Second is about the quadrant. Third one is about their basic angle. And then the fourth one will be the rotation and find out the angle involving. So regarding to our questions here, first for the range. So the range we are solving for 0 and the data in between 0 and 360. But my questions here given, but my situation of this trigo angle here is not theta. So my situation, I have to follow my situation. My situation is theta minus 53.1. So 0 minus 53.1, it will be negative angle. So 360 also minus 53.1, it will become 306.9. So therefore our range, according to our situation of the question we get here, it will start from negative angle, then until 300 something. So means that we not even reach one round, because one round will up to 360. So we just until quadrant 4, some part in the quadrant 4 only. So that will be our first step to measure our rotation, how far our angle involving the minimum to the maximum range here. So this is our first step. So second step is we going to see the quadrant involving. So how to see the quadrant involving? We see the value where all sign teacher crazy. So sign positive means it will located at quadrant 1 and quadrant 2, because this is all trigo positive, this is only sine positive, this is tangent positive, this is cos positive. So I want sine positive. So if involving quadrant 1 and quadrant 2, then we go for step 3. Step 3 is finding out basic angle. How to find out this basic angle? We shift our sign to the value. So remember, we didn't take the negative value. So we want the value only, we didn't take the positive or negative. Positive, negative, just for us to uh, recognize where's the location, where's the direction. So when we shift our sign to 2 over 5, we can get our basic angle 23.6. Means in this small angle here is 23.6. In this small angle is 23.6. Then finally only we can get the rotation to find out the opening angle is how. So we start from for step number 4. Now our theta is leaving, our parts of solution here is leaving theta minus 53.1. We start our rotation. Start negative. Negative means we anti-clockwise. We will rotate from the bottom. So we rotate from the bottom, but we can notice that in quadrant 4 we don't have any angle involving. Even I rotate here negative 53, I didn't see any answer. My answer is in quadrant 1 and quadrant 2. So for negative angle, for this case, we don't have any answer. Then I go back to positive rotation. Start from 0 in quadrant 1. So start from 0, this is my opening angle. So in quadrant 1, the angle involving here is 23.6. Then continue, I go for quadrant 2. So when I want to opening to the rotation quadrant 2, it will equals to half cycle here, 180 minus the basic angle. Then we go for quadrant 3. Quadrant 3 not involving our solution. Quadrant 4 finish until 300 something, means until 300 something here only finish. So that is our rotation regarding our range here, how far we go, how minimum we go, and how maximum we go. So after we rotate according our range, we notice that we have two answers. So we have two solutions. So our final step will be we going to simplify what is our data. So we will add up 53.1. This one we will 180 minus 23.6 and add up 53.1. So this will give us okay. So we go for important step here. Which step is very important that you have to perform it correctly. So from here, of course, the first part is using back our answer from part A, our expression, which is this expression is not very valid for our solving. We use the expression that are suitable for our solving. So this is our concept applying our expression. Then we calculate our basic angle, and then we get our uh, angle in the quadrant related and simplify to the answer. Simplify to the answer means we have this one plus 53.1. So our answer must be expressed in the simplest form. Go back to data. So although you can see here, my first step and second step here, it doesn't give you any marks, but it is important. We cannot skip these two marks because our rotation of our angles is depends on our first step. How far we go, how minimal we go. I want to go as minimal as I can, negative 53, but in this quadrant, it's not involving any solution. So when this happens, we have to refer to our range correctly. So that's why first step and second step just guide us to the correct answer to let us see which is the quadrant that involving the solution and we can do the rotation correctly. So this is how we do the rotation correctly. When we open first quadrant, it is 23.6. When I want to go for second quadrant, I need to take 180 minus 23.6. So other than that, don't have because we can see I want to rotate until 300 something. But this two quadrant is not involving our sign positive value is not involving in these two quadrant. That's why they help us to finalize out this is the two answer. This is the two solution for this equation. Then we simplify it, there will be our final answer. So for range here, so you can see for range here, original come from the question they said data is zero in is between 0 until 360. Okay, so we take from the question original is this, but we have to refer to our situation of our questions here. Our question here, the latest form I want to solve here is not data only. Our angle here is not data only. Our angle here already minus 53.5. 53.1. So therefore, when my angle data minus 53.1, it will go to the same operation for 0 and 360. So this 0 also will minus 53.5. So that's why it get negative 53.1. And then 360 also need to minus 53.1. So that's why it get 306.9.